Okay, the next few problems are about key features of a graph. So what I want to do is I want to go from what I think is something that students have more success on, and I want to end up with the stuff that people struggle with. So I want to start off with just finding the roots right now. So the roots, by definition, they have three other names. Roots can also be called zeros, x-intercepts, or solutions to the function. Roots are always found on the x-axis. So basically this graph, it looks like it has four separate roots. So we just list all of them. So this one is at -3, 0, -1, 0, 1, 0, and 3, 0. Now I'm going to save increasing and decreasing for later, so I want to go on to end behavior. Basically, if you tear up the word end behaviors and just think about what that means, it means how is it behaving at the ends? Where is it going? The thing to notice is even though this graph looks like it's kind of low, these arrows at the end indicate that they go in those directions forever. So if we want, we could also extend them. End behavior basically takes a look at the left side and the right side at extreme values and tries to figure out where the y is headed. So if you notice, the left side and the right side are headed in the same direction. So that already tells us that our end behavior should have the same answer. They're both headed up, so the y's are actually headed towards infinity. So both answers are positive infinity. Okay, now for the maximum and the minimum. The maximum is going to be the highest point. If you think about this graph being like a roller coaster ride, it's going to be the part that goes up and then comes back down. So basically like the funnest part of the roller coaster. In this graph, it appears that the maximum is located right there at 0, 9. So our maximum is 0, 9. Now the minimum is the exact opposite. The way I think of it is if I was to pour water across the entire part of the graph, where would the water collect? This graph looks like it would actually collect in two places. It would collect down here, and it would collect in here. So basically that means that both points are considered to be minimums. So one of the minimums, it looks like it's at -2 and -15. And the second one is at +2 and -15. Now back to odd, even, or neither. This graph, it looks like if I fold it across the y-axis, it would be an exact copy of itself. So that means that this one is even. And for the average rate of change is just a fancy way of saying slope. So every slope is determined by this formula here, y2 minus y1 over x2 minus x1. And they want us to find it between the maximum and the minimum. Well, to be honest with you, we only have to do it once because the other one is just going to be the opposite sign because they're the same distance apart. So if I was to use 0, 9, and I don't know, -2, -15, one of the maximums and minimums. If I did my formula, I would label this as x1, y1, x2, y2, and then I would just plug it into the formula. So we would have 9 minus -15, and then on the bottom we would have 0 minus -2, in which case the two negatives turn into a plus. So we end up with 24 on top and 2 on the bottom. So ultimately, our average rate of change is 12. Now, because there's a second minimum, if we were to do the other side, all that's going to do is give us a -12 because they're the same distance underneath the y-axis, or actually the x-axis, and they're the same distance away from the y-axis. So that's why it gives me two different answers like that. Okay, so now, back to domain and range. When I talk about the domain and range, I want to talk about the extreme x values. How far to the left and how far to the right does this graph go? Now, don't forget, graphs never go straight up because if they did, they would be undefined. So in our beginning graphs, we're never going to have anything that's undefined. So even though it appears to go straight up, it actually goes outward. And this one also goes outward. They go outward forever. So eventually, This graph will reach positive 10. It's just going to be super, super high. So this graph, if I look at the left side, it goes forever. And if I look at the right side, it goes forever. So that basically means that the domain is all real numbers. We write that as negative infinity to infinity. Now for the range, you have to be a little careful on the range because the range is the y value. We want to go from the bottom to the top. The bottom is clearly at negative 11. It doesn't matter which negative 15, sorry. It doesn't matter which one you look at. They're both at negative 15. So our range, the lowest it goes is at negative 15. And those are both closed circles, so we use a bracket. The highest it goes is actually not at 9. Because remember, arrows mean that they go forever in that direction. So our graph actually goes beyond 9. In fact, it goes forever up. So that's going to be a positive infinity. Okay, for the last one, this is the one that students struggle with the most. The last one is increasing and decreasing. So I think again about that roller coaster. I'm going to color code this graph to show you the parts where the graph is going down and where the graph is going up. Down is going to be red, up is going to be blue. So I have a few sections where this graph goes down and a few sections where the graph goes up. Now, as we're doing this, the only thing that really matters is where the graph changes colors. Wherever the graph changes colors, we're going to go over to the x-axis and we're going to write down whatever number that is. So it looks like at negative 2 it changes colors, at 0 it changes colors, and then again at positive 2 it changes colors. Now the extremes, they're going to be infinity. So to the right it's going to be a positive infinity and to the left it's going to be a negative infinity. Essentially what we've done is we've put our intervals of increasing and decreasing along the x-axis. So if we were to look at an interval where it's, what do we have first? Increasing. The increasing would be the blue ones. So for increasing, it starts at positive 2 and it stops going up at 0. Oh, I'm sorry, negative 2. Goes from negative 2 to 0. So that's going to be our first increasing interval, negative 2 to 0. The second increasing interval looks like it starts up at positive 2 and it goes off to infinity. So we put a union because there's a gap and it starts up again at positive 2 and goes off to infinity. Get rid of these. I'll need these for right now. The last part of this is to look at the red sections. So the red sections, if you look at the graph from left to right, those are your sections that are going to be decreasing. So the first interval would be from negative infinity all the way to negative 2. So we go from negative infinity, because this graph goes forever, negative infinity to negative 2. And then we put a union because there's a gap. And then the graph starts going down again at 0 to 2. So we go from 0 to 2.